Hi everyone, I've been building an event planning app from scratch with three main constraints. First, I'm using Rust as the main programming language. Second, I'm not using any modern UI framework. And third, I'm building it as a fully server-side rendering application. In the last episode, we set up the web server using ActisWeb, a powerful Rust library, and I shared some of the frustration I had while learning Rust. In this video, we'll dive into the authentication flow and set up the database connection. So let's get started. My goal for the authentication flow in this app is to implement a passwordless process. I believe it enhances the user experience by simplifying the logging process. But before we dive into that, let's briefly review how authentication works in general. At its core, authentication is the process of verifying that a user is who they claim to be. When you enter your username and password into a website, you're trying to prove your identity. The system checks your credentials, and if they match, you're authenticated. In many modern applications, you might see options like login with Google or login with Facebook. This is where OAuth and OpenID Connect comes into play. These protocols allow apps to outsource the authentication and authorization to trusted providers, so they don't need to handle password directly. OAuth is mainly used for authorization. It lets an app request permission to access specific information, like your email or contacts, from another service on your behalf. OpenID Connect builds on OAuth by adding authentication. Not only can the app access your data, but it can also verify your identity using an ID token issued by the provider. So with OAuth, you give the app permission to access your information. With OpenID Connect, you also verify who you are, which is why it's popular for social logins. If authentication proves who you are, authorization determines what you are allowed to do. After your login, the system decides what resource or action you can access. For example, whether you can edit your profile, but not someone else. OAuth manages this process by issuing access token. This token defines what part of the app or data you are authorized to access, and the app checks to see if you are allowed to perform certain actions. After authentication, the app needs to keep track of your logging status. There are two common ways to do this: sessions and tokens. In a session-based system, once you log in, the server creates a session and stores your logging state. The session is tied to a unique ID stored in a cookie, and every time you make a request, the app checks this ID to confirm you are still authenticated. With a token-based system, you get a token after logging in. This token contains your identity and permission, and the app uses it to verify your identity. I hope this explanation was useful. Now let's talk about the OAuth setup. You will need to create an account and a new application in the OAuth dashboard. Next, you will configure the setting, including your app callbacks URL, where the user will be redirected after logging. OAuth will then generate credentials like your client ID and client secret, which you will also add to your app configuration. Auth0 also provides a customizable hosted login page, so you don't need to build one from scratch. Now let's start coding. Since Auth0 doesn't have a Rust SDK, we need to interact directly with their API. First, we need to authorize the app by redirecting the user to the Auth0 authorization endpoint. This sends a request to Auth0 along with your application ID and redirect URL and the scope of the data you want to access. Auth0 then presents the login page for the user to authenticate. After the user logs in, they are redirected to the app with an authorization code. So we need to create a callback API endpoint where the user can exchange this code for tokens. We make a POST request to the Auth0 token endpoint, and if the request is successful, Auth0 sends back an access token, ID token, and optionally a refresh token. I decided to use a session-based approach for authentication. Once we have the tokens, we can leverage this active session crate to manage session on the server. This crate allows us to securely store the token and create a session for the user. As middleware for your app, Active Session will automatically handle the creation and management of session IDs. It sends a session ID token to the user as a cookie, which the app can use to recognize the user in subsequent requests. This way the user stays logged in without needing to send the token with every request. That's it for the authentication flow. Now let's talk about the database. SQL databases like PostgreSQL or MySQL are relational, meaning data is stored and structured table with predefined schema. This structure makes SQL great for complex query, join, and transaction, where data consistency is crucial. On the other hand, NoSQL database like MongoDB store data in a more flexible and structured format like document, graph, or key value pairs. This makes NoSQL ideal for applications that need to handle large volume of data without strict relational constraint. For this project, I've chosen to use a SQL database with Supabase. But instead of using an abstraction like an ORM to generate SQL query, I'm opting to write raw SQLs directly. ORMs like Prisma abstract away the SQL code by providing high-level interfaces to interact with the database. But by using raw SQL, I get full control over the queries. I can optimize them for specific use case and avoid some of the limitations that come with abstractions. But the truth is, I'm mostly prioritizing learning here, which is why I've chosen to write raw SQLs for this project. For the database connection in the app, I'm using the SQLx library. SQLx is an async pure Rust SQL crate that allows to write raw SQL very safely. And ActiveWeb has an application level store that let us pass a shared state throughout the application, like the database connection pool, to share the database connection across different parts of the app. This ensures that we can access the database in any API handler without creating a new connection for each request. Alright, that's a wrap for this video. In the next one, we are going to switch gear and focus on building the UI. I will be using Ascama and Tailwind CSS to handle the HTML, and I will add HTMX to bring in some client-side reactivity. Thank you so much for watching. See you in the next one.